Hello everyone, welcome to my channel. I am Balaji Chandrasekharan. Today I will be discussing the implementation of HashMap in Java, an important topic within the collection framework. A HashMap in Java is a data structure that stores the data as key value pairs. It uses a hash table data structure to implement the map interface, allowing for faster retrieval of values based on their keys. HashMap in Java implements serializable, clonable, and map interfaces. Java HashMap extends abstract map class. The direct subclass of the HashMap class is linked HashMap. HashMap allows one null key and multiple null values. This means you can have one key with a null value, but you can have multiple key value pairs with null values. Internally, HashMap uses hashing to efficiently store and retrieve elements. The hash code of the key determines the index where the value is stored in the underlying array. HashMap does not guarantee any specific order of its elements. The order in which elements are stored and retrieved may vary. HashMap stores entries into multiple singly linked lists called buckets or bins. Default number of bins is 16 and it is always the power of 2. HashMap uses hashcode and equals methods on keys for get and put operations. So HashMap key object should provide good implementation of these methods. This is the reason immutable classes are better suitable for keys, for example, string and integer. You can iterate over the elements of a hash map using the various methods like for each, iterators, or streams. HashMap in Java use its inner class node with types k and v for storing mappings. HashMap works on hashing algorithm and uses hashcode and equals method on key for get and put operations. HashMap use singly linked list to store elements. These are called beans or buckets. When we call put method, hashcode of key is used to determine the bucket that will be used to store the mapping. Once bucket is identified, hashcode is used to check if there is already a key with same hashcode or not. If there is an existing key with the same hashcode, then equals method is used on key. If equals method returns true, then value is overridden. Otherwise, a new mapping is made to this singly linked list bucket. If there is no key with the same hashcode, then mapping is inserted into the bucket. For HashMap get operation, again get hashcode is used to determine the bucket to look for the value. After bucket is identified, entries are traversed to find out the entry using hashcode and the equals method. If match is found, value is returned, otherwise null is returned. There are much more things involved such as hashing algorithm to get the bucket for the key, rehashing of mappings, etc. But for our working, just remember that hash map operations work on key and a good implementation of hash code and equals method is required to avoid unwanted behavior. When working with a hash map, hash collisions can occur when two or more keys have the same hash code but are not equal according to the equals method. To handle hash collisions, HashMap uses a technique called chaining, where multiple key value pairs with the same hash code are stored in the same bucket as a linked list or a tree in Java 8 and later versions. When you add a key value pair to the hash map calculates the hash code of the key using the hash code method. This hash code determines the bucket or index where the key value pair will be stored in the underlying array. If multiple keys hash to the same bucket, that is, hash collision occurs, the hash map handles it by storing the key value pairs in the same bucket as a linked list or a tree. Each bucket in the array can hold multiple key value pairs. In old versions of Java prior to Java 8, when a hash collision occurred, the key value pairs with the same hash code were stored in a linked list within the bucket. However, starting from Java 8, if the number of elements in a bucket exceeds a certain threshold, tree height threshold equal to 8, the linked list is converted into a balanced tree, that is a red-black tree, to improve the performance. When you want to retrieve a value from a hash map, the hash map calculates the hash code of the key and determines the bucket where the key value pair is stored. It then iterates through the linked list or a tree in the bucket to find the key value pair with the matching key. If found, it returns the corresponding value. While chaining effectively handles hash collisions, excessive collisions can degrade the performance of hash operations. If many keys hash to the same bucket, the linked list or tree in that bucket can become long, leading to slower retrieval times. To mitigate this, it's important to choose a good hash function and ensure that the keys are evenly distributed across the buckets. In a hash map, rehashing is the process of resizing the internal array known as the hash table and redistributing the key value pairs when the load factor exceeds a certain threshold. The load factor is the ratio of the number of key value pairs to the number of buckets in the hash table. Here is how rehashing works in a hash map. HashMap maintains a load factor threshold, typically 0.75. When the ratio of the number of key value pairs to the number of buckets exceeds this threshold, rehashing is triggered. When rehashing is triggered, the size of the internal array of hash table is increased, typically doubling the number of buckets. This is done to reduce the number of collisions and maintain efficient performance. All the existing key value pairs are rehashed and redistributed into the new larger hash table. Each key value pair is assigned a new bucket based on its updated hash code. Rehashing is an expensive operation as it involves iterating through all the key value pairs in the map and redistributing them again. However, it ensures that the hash table remains sufficiently sized to prevent excessive collisions and maintain efficient performance. After rehashing, the capacity of the hash map increases, allowing for more key value pairs to be stored without significantly affecting performance. For example, I created a hash map with an initial capacity of 2 and a load factor of 0.75. When I try to add a third key value pair, the load factor exceeds the threshold, triggering the rehashing. As a result, the, the hash map is resized and the key value pairs are redistributed into the new hash table. With this, we came to the end of the session. Thanks for watching my video.